today's video we will be solving the LeetCode's 567 permutation in string problem. It's a medium difficulty problem, and I think this problem introduces some interesting ideas how to solve this kind of tasks, and yeah, we can discuss them in this video. So yeah, let's switch to the code, to the problem description. Yeah, I have written the description here as well. So given two strings s1 and s2, return true if s2 contains a permutation of s1 or false otherwise. In other words, return true if one of s1's permutations is the substring of s2. And here I also added the definition of a permutation. A permutation is basically a rearrangement of all the characters of a string. So let's go through an example. So if s1 is AB, s2 is this string here, the output in this case would be true. And why? Because the permutation of s1 is a substring in s2. So AB, a permutation of s1 would be BA as well. AB and BA are the permutations of s1. So, and BA is a substring, we can see it here, of s2. So s2 contains one permutation of s1, which is the BA permutation. On the other hand, there is another example where s1 is AB, s2 is a slightly different string. In this case, the output would be false, and the reason for that is because AB nor BA are substrings of this s2 string. So because of that, the program would return false. And also there are some constraints which basically tell us that both s1 and s2 are non-null and non-empty strings, and each containing length no longer than 104, and s1 and s2 consist of lowercase English letters. So we can assume that this is always true, or we can create a validator method that would check for these constraints. So yeah, let's try to implement this solution. So in my opinion, there are two major things that we need to figure out how we can solve. First thing would be how, given two strings with a similar length, with the same, let's say string ABC and string BCA, how we can say whether these two strings, whether a permutation of the first string is equal to the second string. So let's assume that both strings have the same size. So the goal is how to say whether this string, a permutation of this string, is equal to this string. So that would be like the first sub-problem that we need to figure out how to solve, and we can call it check if a string is a permutation of another string and same size, with the same size. So for instance, in this case the answer would be yes. But on the other hand, if we take string A, B, C and string abd, the answer would be no, because any permutation of this string abc, and permutations would be abc, acb, bca, abc, acb, bca, bac, and then permutation that starts with c, cab, cba. So those are the permutation of the string abc. Maybe I missed some of them, but anyway, as you can see here, none of these permutations are equal to the second string, so that's why the answer would be no in this particular case. Here it's yes, because a permutation of abc is bca and it's equal to bca, so the answer is yes. So that's the first sub problem that we need to solve, and the second sub problem that we need to figure out how to solve would be if we have this s2 string, we basically need to iterate through all of the substrings of it. So let's say we have the second sub problem would be how to iterate through all substrings of a string. So let's say we have this s2 string which is equal to this. So a substring would be the first row, and let's say that the s1 is equal to abc. So here s1 has size of 3. So in this case, we would need to iterate through all of the substrings with a length of 3, because we need to find a permutation of this string here. So how can we do it? Well, we can use the sliding window approach. So we can take the first 3 strings, and this would be the first substring. The second substring would be, we will just move one step further. So we will take the next letter, B, but we will remove the first letter, E. So the second substring would be IDB. The third substring would be DBA. The fourth substring would be BAO, etc. So that way we can iterate through all substrings of a given string. And finally, to solve this problem, what should we do? We should check if any permutation of S1 is equal to any substring of S2. So we will go through all substrings and check if they are equal to any permutation of S1. So how can we efficiently solve this problem? One way would be we can print all of the substrings, all of the permutations of a string, and then we can go through all substrings here and check if any substring is equal to any permutation. Literally do what it's written here, but that wouldn't be that efficient. We can consider maybe a slightly more efficient solution. So the key thing is to figure out when we are comparing two strings, let's say ABC and BCA, and when we want to check whether any permutation of the first string is equal to the second string, assuming that they have the same size as here, what's common for any permutation of a string with another string if they are equal? Well, the common thing would be the frequency of each letter within a string. So the frequency or the number of letters are equal. So what we need to check if a permutation of this string is equal to this string, we need to check if they basically have the same number of letters. So the same number of A, same number of B, same number of C's, etc. And then it's simple. We can create, let's say, a structure that would tell us efficiently whether that will translate any string efficiently to the number of letters structure. So we can use a hash map, for instance, where a hash map would count the number of letters for each string, and that would be sufficient to tell us whether a string is a permutation of another string. So we can simply count the number of letters in the two strings, and if those two structures that holds the number of letters for each string are equal, then we can say that this string is a permutation of this string. So if you check on this example, here for the first string, A has 1, B has count of B is 1, and count of C is also 1. On the other hand, for BCA, we have something similar. A is 1, B is 1, C is 1. And because these two counts are equal, then we can say that ABC is a permutation of BCA. On the other hand, if we check for the second example, ABC and ABD, here we have A has count 1, B 1, C 1, D 0. There is no D in the first string, and for the second string, A is 1, B is 1, C is 0, there's no C, and D is 1. So if we compare these two structures, we can say that they are different, they differ. So because of that, we can say that ABC is not a permutation of ABD. So that's one thing. For the second problem, how we can iterate through all substrings of a string, we can use the sliding window approach. So we will go first 3, then we will shift one step further at every step, and that way we can check all of the substrings. So we can go for every single substring, we can count the number of letters, compare it to the number of letters in S1, and if any of the two counts matches, if any substring letter counts matches the S1 string letter count, we can return true. That means that we found a substring which is a permutation of the first string. Otherwise, if there is no such substring in the second string, we can simply return false. Let's implement this in code. So how can we start? So usually if you get this question as an interview question, let's say you're applying for company and someone asks you this question during the interview, they might skip these constraints. So it's really important for you to at least ask whether can we assume that these two provided strings are never going to be null, or whether this second constraint is true. Can we assume that all strings consist only of lowercase English letters? And they say yes, then yeah, we can assume that. Otherwise, it's a good practice to add some initial validations of the provided strings and throw some exceptions. For instance, illegal argument exception if any of these constraints are not satisfied. So yeah, we can quickly do that. So we can create a helper method called public void validate input, and we can say something like string s1, string s2. By the way, I'm implementing the solution in Java Java language. Yeah, but I feel like it would be relatively straightforward to implement a similar solution in any other language. So we can say something like this: if s1 is null, or s1, or we can say something like s1 to lowercase is not equal to s1. So that means we are assuming that all are lowercase English letters, but if it turns out that an input string contains uppercase letters, then we can assume that as an invalid input. So if s1 converted to lowercase is not equal to initially passed s1 string, then we can consider that as invalid input. Or we can do the same for s2. If s2 is null, or s2 to lowercase is not equal to s2, we can throw an illegal argument exception. I can say simply strings are valid. We can say provided strings are invalid. Throw new illegal argument exception. So additionally, we can check for the len. So we can say also something like and s1 is or s1 is empty, or s2 is empty. We can also check for that. And there is also another constraint that the length of both strings should not exceed 104 characters. We can check for that as well. s1.len is greater than 105, or s2.len is greater than 105. So those are all cases which are considered as invalid. So here, what I don't like here is that I use this constant 105 twice. Might be better to create a constant. So those little things might be useful if you are doing this as an interview question, because someone may pay attention to these little details. And yeah, it's always good to create as clean code as possible. So we can create a constant called static final int max len, which is equal 105 or 104. Yeah. So yeah, this would be our input validation method. So we can start this implementation. So as you can see here, I forgot to mention that the main method or the solution will be implemented in a method which is called check inclusion, which takes two strings, s1 and s2, and it would return a boolean value true if if any permutation of s1 is basically a substring of s2. So we can say initially we can return false. And yeah, we can start implementing this. So first let's validate the input strings. So we can simply call the validate input s1 s2. Next thing we should do, we should initialize our structures that we'll be using to count the number of letters. So initialize the inner structures. So what kind of inner structures we will be needing? So instead of using a hash map, we know that we need to count the number of letters, lowercase letters, in each string. That means that hash map that we can be using would have maximum of 26 keys. Why is that? Why 26? Because 26 is the number of letters in the English alphabet. So we can create a constant alphabet len, which is 26. Something like that. So instead of using a hash map, a way simpler approach would be to simply create an array of integers where which will be used to count the number of letters in each string. So s1 frequencies is equal to new integer of alphabet len. So what does it mean? So s1 of 0 counts the number of character A. s1 of 1 counts the number of characters B in s1 string, etc. s1 of 25 would count number of character Z or Z in the s1 string. So it's way simpler, and we can calculate in this step. We can simply go through the string s1 and count the number of every single letter of every single character in it. So how can we do it? We know that at least in Java, every character has a code number, ASCII code. So we can simply see which the code of character A. So the code of character A would be in lowercase would be 97. The code of character B would be 98. So they are 97, 98. Yeah, the code of character C would be 99. So what we need to do, and here we need to basically translate these character codes to 0 to 25 numbers. So what we can do, for every single letter we can simply subtract the code of the character A, and that would result in basically we will translate the code of every character to 0 to 25 array. So how can we count the number of letters and populate this S1 frequencies array? So we can say for int I equals 0, while I is less than s1.len I plus plus, and we can say S1 frequencies of S1 get character at I minus code of A. So it will, in Java you can do something like this, and basically for every character, when we subtract the code of A, so it will automatically convert this into integers, and we can simply increment the number. Because this S1 frequencies is an array of primitive integers in Java, by default they all have a default value 0, which is good in our case, so we don't need to initialize this string. It's already initialized to 0, so we can immediately just increment whatever the value, and it would work as expected. So this way we have the number of letters of the first string, S1 string, placed into this array size 26, which is called S1 frequencies. We also need another array or map, which would be called S2 frequencies, which will also have the length of 26, or the alphabet len, and it will be used to count the number of letters in every single substring of this S2 string. How we can populate it? So now it's time to check for to iterate through all substrings and check whether S1 is a permutation, or if any permutation of S1 is a substring of S2. So now it through S2 and check if any permutation of S1 is a substring of S2. How we can do it? So we can iterate through the second string while I is less than s2.len I plus plus. So it will start from the first letter, and given, let's say that S2 has 10 characters and S1 has 3 characters, so we need first to reach the first 3 characters. So we need to check if a string, if we have reached the first 3 characters. So first thing we could do, we can simply increase the number of letters for the first string, for the first letter in the s2 string. So we can say s2 frequencies of s2 dot char at I minus a. So we can translate the code plus plus, and then we can check whether we have reached the length of a substring. In order to track all of the substrings, so as I mentioned here, we will be using the sliding window approach. We'll check first 3, then we will move one step forward and one step forward for the third substring. So we need to somehow to keep a track of the first letter in the current substring. In order to achieve that, we can, before we enter this for loop, we can create an integer. We can say substring or substring sub start, which is initially equal to 0. Okay, we can increment the s2 frequencies structure, and then we can check if we have reached the number of characters, if the substring has s1 has the size equal to s1 size. So how can we do that? We can simply check if the current character index minus start index, and we need to add 1. So this is the length of the current substring, is equal to s1 length. So maybe I can add this parenthesis just to make it more clear. So I minus substring, so in the first iteration when I is 0, 0 minus substring is 0 plus 1 is 1. So the first substring has length of 1. So if we have reached the s1 length, let's say that s1 has the length of 3. So in the first iteration this condition is not satisfied, so we will just skip it. But once we reach it, what we need to do, so we have reached it, so what we need to do, s2 at this point will have the number of letters of the current substring, and we need to compare s2 frequencies with s1 frequencies. So we need to compare these two 26 sized arrays, whether they're equal. So that can be simply done by iterating through both arrays. So we can implement that method, or in Java there is already a utility method called in the class arrays, which is called equals. That method is called equal, and we can simply pass s1 frequencies and s2 frequencies. So if these two arrays are equal, then we have found a single permutation of s1 which is equal to a single substring, or we have found that at least one substring of s2 is equal to a permutation of s1. So in that case we can already return true, and yeah, that would be enough to return true in this case, because our goal is to return true if any permutation of s1 is equal to any substring of s2. Otherwise we can continue. But what we need to do, if this is not satisfied, we need to remove the last or the first letter in the current substring from the S2 frequencies map. So because we in the next iteration that letter will be basically removed, and we will add the another letter at the end of the substring. So how can we do it? We can say S2 frequencies of start substart minus minus, right? So we are removing that last that first letter of the current substring from the S2 frequencies map. And also we need to increment this substring start. So yeah, we can do it here, but I think it would be nicer if we simply do it here. So this way, because plus plus is placed after the substring variable in Java, it will first decrement the substring, the substart index of the S2 frequencies, and then it would increment the index itself. So this is basically just a nicer way to write this piece of code. And if this is correct, yeah, this should be the overall solution of the problem. So now we need to test this approach. So we can go to the main function. We can create a solution instance, and we can simply print ln solution.check inclusion for the two strings. Okay, we can start with two empty strings. The assumption here is that we wouldn't pass the validation step, so it would throw an illegal argument exception, which is true. Illegal argument exception provided strings are invalid. So let's start with the examples here. So with AB and this string here, it should be the answer, the output should be true. Oh, it's false. So we have a bug. So let's debug this. So let's see first S1 if it contains the right values. So S1 is AB, right? So yeah, S1 frequency has 1 1 on at the first two places, which is correct, right? So let's move forward. A B C D E, this is correct, right? Oh, yeah. Next is I. This is also looks correct, but this should be false, right? And now we need to remove first E, okay? Oh, and here it's -1, you see. So here is the bug. So this line here is invalid. Why is it invalid? Well, we just decremented what's in substring which was 1, and so which was which was 0, and at that value, at that place we decremented here to -1. We should have decremented this value here. So that's the bug. Let's quickly fix this. So what we miss here, so we need to remove the value of, so we need to convert s2.char at substart minus a. So we need to decrement the value of of the letter from the substring and not the substring index as directly, and we need to increment it further. So if this should solve the problem. Yeah, now it's true. Okay, so obviously this is a single. Okay, let's try with another example where it's obviously not true. Let's say this should be false, because none of the permutation AB or BA are a substring of this second string. Yeah, here it's false. So there are a lot of edge cases, so I don't want to go through each of them, but instead I created a solution test class where I added a lot of different edge cases. So here we have some basic cases, then we have single character cases, then we have same length strings cases, then we have repeated characters cases, longer strings cases, overlapping characters cases, when s2 is larger cases, some edge cases as well. You see A and A should return true, for instance. So I created this solution test where I'm checking against all of these different cases. So instead of me testing manually for every single case, I'll just simply create solution test instance, and I can simply run all of these cases. As you can see here, all test cases passed, which means that this solution seems to be correct. And finally, let's just quickly discuss the overall time complexity of this solution. So here we have to validate the input at the beginning, which is a simple check which takes constant amount of time. So it's a relatively quick check. This initialization part takes, we create an array size with 26 locations. So to initialize this S1 frequencies array, it would take 26, so it would iterate through this fixed size array. So we can say that this part also takes big O of 26, which is basically equal to big O of 1, which has a constant complexity, so quite quick. And finally, here we create an S2 frequency, the S2 frequencies array, also with limited to 26 locations. And here we iterate through the S2 length string. So we have a linear complexity just to iterate through the S2 string, and for every single substring of len which is equal to S1, we compare the two arrays, and how we can implement this comparison, we can simply iterate through both arrays. They all have 26, the length of 26, so constant size, and compare corresponding letters or integers, and if any of them are different, we can simply return false, otherwise we will return true. So this also takes O of 1. It has constant a constant complexity. And so yeah, this is also a single instruction, or it has constant number of instructions. So overall, the time complexity of this solution would be big O of S2.len. So it has a linear complexity. So yeah, that would be all for this video, and I hope you liked it. If you have any question, please do let me know in the comment section, and thank you for watching. Bye.